Welcome back to our attendees. Our next speaker is with us already, Mr. Mark Ossel, Member Coordination Group, Smart Energy, European Commission, Board Member, OSGP Alliance, and at OSGP Alliance. Speaking on today's topic, the changing role of the smart grid from passive power distribution infrastructure to active and agile broker of energy flows. Over to you, Mr. Mark.
Thank you very much, Melvin, and thank you for organizing this event and giving me the opportunity to share my experience in this interesting topic. The topic, energy transition, close to my heart. I've been involved in this for the last 20 years, been involved in most of the smart grid, smart metering deployments in Europe, Middle East, and Africa. The changing role of the smart grid. And then in the second part of the line, it says, from passive power distribution to active and energy broker. So this is about the DSOs, the changing role of the DSOs, it could be mentioned as well. Now, as I said, the energy transition is close to my heart, and it's still a topic, despite the fact that we're already discussing it for, well, 20 years or more. But the change is happening as we speak, and is significant. From a few large power plants in the old days, moving to many small power producers, solar panels, heat pumps. It's all getting there, and a lot faster than expected due to subsidizing by governments, but of course as well, the efficiency of the technology and the price points have changed dramatically. Instead of centralized and national, in most countries, it's now moving to a decentralized and in fact, privatized utilities. The large power plants and lines are still there, but it's changing as we go to the decentralized microgrids. And the distribution of energy, which went for 100 years from top to bottom, it now basically goes bi-directional. And I will state a few more lines on that consumer. And from a passive consumer only paying for energy, now basically becoming an active participant in the grid. So this picture shows the energy flows. It goes from anywhere to everywhere. The decentralized generation, the vehicles pulling energy, but also basically can be used as storage and provide back to the grid the energy when needed. The decentralized generation by wind or solar, hydro. The loads, on one hand, become significant, much more devices being plugged in. On the other hand, more and more buildings becoming energy neutral. Now, I could state in this picture as well that is this vision or reality? Well, for some countries, it might still be a vision, but for quite some countries, it's already reality. If you look in Western Europe, quite some countries have trouble managing stability of the grid. The centralized generation still going on, but the speed with whom people still installing solar panels on rooftops, on buildings is significant. And it makes basically the grid unstable. Utilities have trouble with voltages, with frequencies, but also with distributing the energy flows, vice versa. And in quite some countries, it's already the case that they cannot manage it. So from the old view, where we talked, for instance, on smart metering as a first step into smart grids, the old view was, well, you don't have meter readers anymore, you can now read them remotely, and people don't need to be doing self-reads, and you only can be connected remotely. Those were the main areas of interest, and what it meant for the consumer. For the utilities, it was less fraud, it was billing. And still, many utilities implement smart metering with the old view in mind. And regulators, part of the problem, only allow investments for the old way of smart metering. But in the new way, what is required is that pro-consumer, he produces and consumes, he should basically have the ability with a device which can show how much he's generating, how much he's feeding back into the grid. he will have a choice of packages, financial packages, depending on his contract. And the distribution operator, sure, they can still reduce energy losses. They can reduce their operations and maintenance costs, do better asset management if they do it properly, and using demand-side management, decrease peak demands. But maybe most important, they would be able to manage the grid, where all the dynamics are changing big time and forever. And that basically means they need to maintain an SLA, but with the old infrastructure and capabilities, they're not able to do so. The European Commission has been really driving this change through the Clean Energy Package, the CEP. And let me show you some of the things they're now enforcing. If I take the electricity regulation, which is now basically to be implemented in every country since 2 years by the regulators, it basically has the principle of consumer empowerment. And they are basically, they should drive market-based incentives. The distribution company will have a modest task of deployment of smart grids and smart meters. So this is not anymore just transport of electricity, but really, truly act proactively in this. The directive even goes a bit further in specific defining the roles and responsibility, like consumer rights, market participation regulators, and citizen energy communities. Yeah? And if I dig in a bit more in the consumer empowerment chapter, it says that they are entitled to request dynamic price contracts, to be engaged in demand response, self-production, self-consumption, storage, and sale of electricity. And communities have the right to engage in local energy generation, distribution, aggregation, storage, and energy efficiency services. They can own, establish, purchase, and lease a distribution network. These are significant statements, which now basically are enforced on the DSOs to basically support this change. If you now see the drivers in smart metering, there's quite an interesting change. The market drivers. Now the DSO starts to understand that digitizing the distribution grid is key to optimize that network. And then you see as well enabled tariffs and so on and so on. So there is a change taking place with regards to the market drivers. The DSOs start to understand they need to invest in that future, which will come. And in fact, it's coming faster than they expected. And I can tell you, they're in fact, by far, they're not ready for that world of tomorrow. That world of tomorrow, I call it here Smart City 250, but I could call it Smart City 230 as well. While in some countries, the speed of change is significant. For instance, there's a kind of saying that solar panels spread as fast as COVID, meaning if somebody in a street takes solar panels, soon thereafter the neighbor takes them as well, and the whole street will have solar panels. And the same applies to electrical cars, electric vehicles. They spread like COVID as well. And then the problem is that in that specific street, with maybe 20, 30, 40 solar panels at homes, there is more energy feed into the grid than the utility can transport. And more electrical cars charging at the end of the day. So they've got a problem there. That feeder, that transformer is not able to manage that environment. And even worse, the utility even doesn't know because they don't measure the power quality, the voltages, and they don't have insight in the energy flows at the feeder level or secondary transformer at all. So to be ready for that future, then my advice is that every utility should start with sharing and creating a vision, which they share among all the departments in the DSO, but also with the regulator. Share a vision how the world will change and look in 10, 20 years, but then put any investment you do today, put it along that vision and see if it fits and supports that future world. And that basically highlights a problem as well. And because if you look at the key features required in the near future, here you see the key features for a smart grid: security, communication, analytics software, and infrastructure monitoring. There is a vast amount of data, and they call it big data, coming from, if you have 500,000 meters and you read 15-minute or 5-minute values on power quality, voltages, sags, swells, harmonic distortion, whatsoever. There is so much data in there, you basically cannot, without analytics, know what's really important and what's really happening. And the requirement of the smart city, you see there as well, protection and information and services. That basically means new companies providing new services, energy efficiency services, an insight in the generation and consumption on different locations, and of course the optimization. All those different fields of automation and energy are now interconnected. Electric car charging poles, street lights, it's all basically interconnected. So a dramatic infrastructure as well from an IT perspective. This requires a new DSO and a new set of applications for the DSO of tomorrow. And I will start with low voltage grid mapping. A DSO needs to have insight in the topology. And I can tell you, most DSO, even the advanced ones, don't have real proper insight in the energy flows and topology of the low voltage grid. And normally the information went up to the distribution station and not beyond. And the GIS system wasn't updated, and it does not show the true energy flows up to feeder and endpoint level. So the first thing to happen is use data from the last endpoints, which are the smart meters, to basically provide you the proper topology information. Energy efficiency and theft monitoring. When you have a proper system, it will be able to identify the losses, technical and non-technical, as well as the location of it. So basically you will recover money and better basically be doing asset management on that as well. Power quality, outage identification. It will basically generate the report as requested by the regulator, but it will highlight as well where outages occur, in which part of the grid, and basically allow your maintenance staff to be directed there with the proper information. Even secondary transformer monitoring can be put in place as part of the same communication infrastructure, which, by the way, today is still in most cases power line communication, being most reliable and lowest cost, and providing you, in fact, by means of the physical location, more information than any other way. Voltage and load heat maps, so that you don't, let's say, blind guess the capacity requested in feeders and in transformers, but basically you get actual information, identify the hotspots, the heat maps, where significant draw of current is taking place, maybe because of those electric vehicles which spread around. But the same with voltages. If multiple people start feeding into the grid, you will see the voltage going up to a level where you cannot manage it anymore. And if they all would switch off the feed in, it drops. And when it drops, they all start feeding in again. So you get a flip-flop, which you don't want either. Transformer protection, with the current loads and feed-ins of energy, the voltage is going up and down. You basically need to put new measurements in place for transformer monitoring, so you can protect them and take appropriate action if there is an overload on one of the transformers or even on a specific feeder. Failure protection, I mentioned it. Monitor the loss of equipment, meaning even meters which are located at specific strategic points, endpoints, for instance, of a feeder, and will tell you which part of the feeders are basically having a failure, having a trouble. And then to say a few words on security. We have a product called GridWatch, developed as your OGP Alliance, and some of our members are promoting it now, like NES. Security becomes the next level, which keeps a utility DSO awake at night. guess that somebody basically is able to get into your grid, be able to change key of meters, be able to switch off transformers, meters, hijacks your grid. This basically is not, let's say, fiction anymore. It's reality. Intrusion detection starts to happen. I know DSOs, which basically identify, right now, they know there are people, nations, who basically try to get into their grid every week. So we basically now started to run projects where we implement GridWorks, which basically identifies based on the events happening if somebody tries to hack your grid. So before it happens, it basically will raise the alarm that somebody's trying and where he's trying it and by what kind of entry point. And bear in mind with the interconnection of all the subsystems, any light bulb, any thermostat, the transformer, the meters, the solar panel, inverters, all of that are now becoming access points for hackers to get into your grid. So my advice to you, to summarize, is basically start with creating a vision, how the world will look soon, and it will be there sooner than later, and basically put all investments in light of that future vision, which will become reality. Thank you, Melvin. I'm open for any Q&As if there are any.
Correct, Mark. Mark, any latest projects or highlights you have seen lately, which is of your interest and your topic, and you want to talk about it?
Well, I see a significant role for regulators to act upon the changes happening. What I do see, however, is that most regulators do not approve or drive and force investments which are required to be prepared for the future. They basically still look at the investment base for yesterday's world or today's world, but not for tomorrow's. While the regulator, in my view, and then driven by the Minister of Energy, should be the one who drives the change and enforces that DSOs are taking the proper measurements into the future. So those are the ones who should be in the driving seat, but pity enough, mostly that's not the case.
And with the new technologies like smart metering and so many new other technologies coming, what do you think about the new technologies?
Well, technology is an ongoing evolution. And some people can spend a lot of time discussing and selecting what is the best standard, what is the best technology. My take on that is a bit different. I'm a member of various standard committees, and what I do believe is that selecting a standard and then sticking to that for 20 years is stopping innovation. So that's the wrong way of addressing the issue. What one should realize is that technology evolves, and that like your mobile phone or your laptop, that in a few years there is a next generation of technology, faster, cheaper, whatsoever. On standards, of course, Open Smart Grid Protocol, which I represent, is used by about 60 utilities right now, and it's growing rapidly. It's spreading, mostly implementing it on Powerline. But the story is that OSGP is now available as well on RF communication, like LTM or CAT-M, narrowband IoT. It's available on different Powerline technologies, but the point is all of them will change as well over lifetime of the smart metering infrastructure. So more important is there to ensure you have an architecture which allows you to plug in new technology as it becomes available and makes sense. That doesn't mean you need to take technology as a guinea pig, no, only take proven technology, but rest assured it will change and your choices will change over time. So the architecture with let's say, an environment with multiple headends supporting each their specific technologies and an interoperability layer above it, like with SIM, the Common Information Model, which is more and moreover now becoming the de facto interoperability layer, and not the lower level technologies to basically ensure you get from multiple suppliers all the same technology. That's a sort of old way of thinking. have a high-level architecture, XML-based SIM as the interchange between the different islands of automation, the interchange of data, and the common interoperability layer. So yeah, technology evolves, and sure, you can take advantage of it, and that you basically can use different technologies and protocols alongside.
Thank you, Mark, for your presentation and time. I hope to meet you in person in our next event.
My pleasure.
Thank you very much. Have a nice evening.